A run would be getting several successful plays in a row. All right? So if we look at this example right here, with this tennis example, they kept track of 15 plays in a game, or 15 consecutive points. And this is a mixed doubles tennis team. So they lost the first. They ended up losing the first point. And then they went on a run where they won 4 in a row, lost the next 2, won 3 in a row, lost 1, and then lost the last 3 points. So the question says, the W's, they won the point. L's, they lost the point. Determine if these results show that the success or failure seems streaky. So this is what you need to do, is we're going to use these two formulas here. You cannot use the calculator for this. There's not a shortcut using the stat menu on a graphing calculator. So you have to have these formulas available to figure out the p-value. And this is what the formulas represent. Mu is the average number of unbroken runs. We'll talk about that. N plus is the number of positive results, and N minus is the number of negative results. Let's actually figure this out. I'll need your help with the calculator too. Let's figure this number out, mu, using the results we got from the game of 15 plays. So with looking at the sequence right here that I gave you, how many positive plays were there total? And there were 8 wins, 8 winning points. How many losing points were there? 7. So I'm just putting those numbers into the formula, divided by n, and n in this case is the total number of points, which is 15, plus 1. So you use that formula to figure out what the average number of streaks, of positive streaks, should be. So the average number of positive runs or streaks comes out to be about what? What did you get? About 8.5? Okay. So that means in a game where there's 8 successful plays and 7 unsuccessful plays, you would expect there to be on average 8 runs of successful plays. How many runs of successful plays are there here? How many winning streaks are there? There's 1 winning streak, 2 winning streaks, and just winning 1 is considered a streak. So for this particular case, we found out that for us, we got only 3 runs, 3 winning streaks, when we were supposed to get 8.5. So this sounds like a hypothesis test. They're telling us that we should have gotten 8.5 winning streaks, but instead we only got 3. So does this seem streaky to you? There should have been more switches. There should have been 8 little mini streaks of W's. Instead, we got 3 longer streaks of W's. So this means it's streaky, probably streaky or not? Probably streaky. Because look, there's supposed to be, okay, so this is brand new. So look, there were supposed to be 8 of these runs of W's. Instead, there was only 3 runs of W's. The fewer runs, it means that they're more strung together. The W's were more strung together. If it went loss, win, loss, win, loss, win, loss, win, loss, win, there'd be many streaks, many tiny streaks, but it wouldn't be considered to be streaky because it wouldn't be a series of W's in a row. It's more choppy, alternating every other play. All right, so we need those 2 numbers to finish up the work. We also need to figure out the standard deviation. And that's figured out by using this formula here. Don't ask me where the formulas come from, because I'm just the teacher. I'm not the person that creates this stuff. So what we do is we take this answer here that we have, plug it in for mu, and figure out the standard deviation. So it's the square root of 8.5 minus 1 times 8.5 minus 2, and then divided by n minus 1. N minus 1 is a familiar thing. It's the degree of freedom. So if there's 15 in the list, 14 would be the number underneath. All right, so we're gonna need that answer too. So you tell me what you got. I got about 1.9. Tell me what you got. So it'd be 7.5 times 6.5 divided by 14 and then square root it. I wouldn't even use the calculator for the numerator there. So what did you get? 1 point what? 1.857. Okay, so we'll just call it 1.9 to make the math come out a little bit simpler. So these three numbers here that I circled are important numbers to use. And now we can go ahead and complete the hypothesis test. So the first thing we have to do is state the hypothesis. Okay, so it's going to be very similar to what we did before. The whole is that we're told that the average, or we figured out that the average should be 8.5 runs, positive streaks. From our analysis of the tennis game, we only got 3 runs of positives. So we think that the true average should be less than 8.5. A lot of the things we talked about in the last unit apply to this. Question 2. Notice it's the same number here and here. It's mu for both. The first one's an equals, and the second one, in this case, the second one will always be a less than. Because if we want to prove that something's streaky, it means that there's fewer runs. This is only the first example, too. We're going to do a couple more together, and I'll be able to go through a little bit faster because I won't have to explain where how these pieces are coming from. All right, so name the test. Well, the name of the test is a t-test for runs. The conditions are very simple. There are no conditions that are needed. It just has to be a string of positive or negative plays written in order of which they happened. So there's no set number that you need. You don't need more than 30 plays in a row. Obviously, if you have more plays, it's maybe more interesting because you can say maybe more about more than just one particular game, but you can analyze an entire season or an entire career. But you just have to have a string, that's what it says, of positive or negative plays. The significance level, that's up for you to decide. We can go with 5%. The calculations in the curve, still the same, still called the same thing. But in this case, we have to actually use a slightly different formula for t. And actually, that's why I made a mistake on the board yesterday when I wrote that down. The t we usually use is x hat minus mu over the standard deviation divided by the square root of n. But for this particular case, it would just be these three numbers. X is the number of runs we got, which was 3. Mu is the amount we should have had, which was 8.5. And sigma was, or standard deviation was the 1.9 that we got from the work above. So that's telling us what the t-score should be, which is roughly negative 2.9. You can second that. Can I get an amen? Okay, did you get that? About 2.9, negative 2.9. We draw the curve. There's lots of t-curves out there. This t-curve is going to have a degree of freedom of 14. We mark down negative 2.9. shade to the left because the alternative hypothesis said less than. We want to figure out that p-value. We figure out the p-value by doing TCDF, just like before, with 3 numbers. So to finish this thing off, it'd be TCDF with what 3 numbers? To figure out the area under this T curve, it'd be negative 1,000 up to negative 2.9 with a degree of freedom of 14. We'll do it again. We'll try to do it 2 more times in the next 15 minutes. 'Cause I don't know. I can't tell you about my pace. I think I'm keeping a pretty quick pace. You guys are doing a pretty good job keeping up. But you're going to have questions and not even stop to ask. So what would the p-value come out to be? Small or large? The p-value comes out to be about 0.005. Is that close to what you had? And then the 4th step is the conclusion, same conclusions we've been reaching. The p-value is less than significance, so we're going to reject the hoe. Remember, it rhymes. P-value is low, reject the hoe. And what does that mean? The p-value is low, we're going to reject the hoe. So was this game streaky? The hoe is saying that there's no streaks involved. We're rejecting the hoe. So the conclusion is this particular stretch of 15 points, this was streaky. In other words, there was momentum in the game. When one team got 1 point or lost 1 point, it led to more loses and wins. Well, do you have particular questions, or you just want to see a couple worked out? All right, let's do another. Just flipping a coin with heads and tails. So question number 2 on the back. A balanced coin is flipped rigorously and yields the following sequence. So does the sample example show fewer unbroken streaks of heads on a fair coin than expected? In other words, is the luck of getting heads streaky? If you take a look at this pattern of heads and tails, does it look like there were lots of streaks or long streaks of heads showing up? There's a run of 3, there's lots of little runs of 2s, and even some runs of 1. It doesn't look very streaky. So the hoe is probably not going to get rejected. We're probably going to reject the ha on this one, if I set it up the right way. All right. So it says complete a hypothesis test showing all 4 steps and use alpha as 0.01. So let's take it right from the start. The hoe is going to be that the average that we should get is, well, we don't know. We have to actually figure that out from the formula on the front. So the formula on the front said to figure out the average number of runs that we should get, we have to use the formula. 2 times the number of successful attempts. So if we're looking for heads, how many heads were there? 1, 2, 3, 4, 16. So I got 16 too. So there were 16 heads. Heads would be a successful coin flip. That's what we're going to consider. Heads as being good. And how many unsuccessful ones were there? How many tails? 14. So how many total flips were there? 30. You just add those blue numbers together. And then plus 1. Don't even ask me where that plus 1 came from, because I don't even know. Like I said, I just learned this myself on Tuesday. You can see I'm charged up about today. It's kind of fun to do something that you never tried before. Okay, so what was the average number of runs we should have seen? 15.9. Plus 1? 15.9. Want to call it 15.9 or 16? All right, we'll call it 16 just for argument's sake. So the average number of streaks we should have is 16. How many did we have? Let's count it up. How many streaks of heads were there? There was 1, 2 streaks, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10. So the number of streaks I got was 10. So the question is, was it streaky? In other words, was it less than 16? Was less than 16 for this particular sequence. So the question is, was it far enough away from 16 that we should actually be concerned? Because a sample almost never will agree with the true average. Most always will be off a little bit. The question is it that far off? Well, we're about to find out when we figure out that p-value. So there's your first step. The second step's actually a lot easier, because the second step is to name the test. This is what's it called again? T-test for runs. And the conditions, there aren't really no conditions. We just have a sequence of yeses and nos. We're good. And then set the significance level. They even told us what it should be, 1%. For the third step, you're going to have to figure out the other important number, which would be the standard deviation. So we have to use that wacky formula on the front of the worksheet again to figure out what the standard deviation is going to be. So we have to follow that formula and just plug in what we know. We know that the mu is supposed to be 16. So we know we looked at 30. We looked at 30 values, or 30 flips. So this would be a 29 underneath. So it's just 15 times 14 divided by 29, and then square root it. We're totally on the way. So 2. We won't round it too much. Just leave it as 2.65. 9. Okay. Sometimes with standard deviations, they're a little sensitive. If you round a little bit, you can throw off your answers quite a bit. All right. So we're on to the third step. The third step is to do the calculation of t, and this formula is different than the one we've been using, just a little bit. All it is just that. So t would equal, well, how many runs did we get? We still have to figure out, oh, we have it, right? No, yeah, we do have it. X is 10. So it should be 10 minus 16 over 2.69. Okay, the t-score comes out to be about negative 2.2. That's an important number on the page. Not the most important. Okay, we're going to draw that t-curve. Use TCDF to figure out that probability. We're at negative 2.2. And we're going to shade to the left. So you do a little TCDF action on your calculator using the numbers negative 1,000 to negative 2.2. And then you just need the degree of freedom, which is 1 less than how many flips we did? 29. So the p-value, that's the most important number on the page, comes out to be small, but not that small, 0.018. So it's a small probability, but remember on that last step, we have to compare it to the significance level. The p was 0.018. Is it higher than 0.01? just a little bit. So the p-value is greater than the significance level. So the conclusion is reject the ha. And you would say that this does not show. So the conclusion is the flips, even though we got some streaks involved, the flips do not show streaky behavior. So if you were trying to test whether or not a coin was a trick coin or not, you want to show that there aren't lots of streaks of heads. Like heads isn't going to show up more often than tails. So the flips do not show streakiness. Which is what we're trying to figure out. Are there streaks or runs of heads that are unnatural if you just flip these coins? I like the way it finished up in the last question with like a psychology example. So a person, psychologist or even a patient, it doesn't have to be mental health, it could just be physical health. Are there strings of good days or bad days with the patient? Do they come in runs? I think if you're trying to establish if somebody's having some trouble mentally, you're going to have maybe strings of bad days and strings of good days. Typical person probably goes somewhere in between where you have a lot of medium days, or maybe some slightly good, some slightly bad. So whatever, this might be a patient, how they feel, how their pain feels. Could be someone in the hospital after surgery, knee operation, whatever it might be. But I was kind of thinking of like this in terms of psychology. So we got a string here. Question is, I wonder if we can do this in 4 minutes. Probably not. Probably not. But what we'll do is we'll save this for Monday and do a little mini repeat of the lesson for the people working on the test. Here's the homework assignment